Let's look at the product rule here. So if we have two functions, f and g, both differentiable at x, then their derivative, or I should say the derivative of their product, is going to be f prime of x times g of x plus f of x times g prime of x. So this is a little bit more complicated, just like we promised on the previous page, right? This is not equivalent to the derivative of f times the derivative of g. Now, to see why this is true, we are going to have to maybe prove this. Let's start off with that derivative of f times g. If we were to use our limit definition, we have the limit as h approaches 0 of f of x plus h times g of x plus h minus f of x times g of x, and then all over h. I'm going to write my equal sign a little bit further back here. I usually like to keep my equal signs in line so it's easy to see one step to the next. But here it's going to be a little bit longer, so I'm making myself some room. And so far everything looks the same. Right, and here's the trick. We are going to subtract f of x plus h times g of x. And then we're going to add that same thing. And then we have our minus f of x times g of x. And then this is all over h. Okay. And so that part that I've included there in green, if you notice, it's just technically 0. I've subtracted and added the same thing. Okay. So we've made this look different, but it's not equal to anything different. So we have the limit as h goes to 0. And what I'm going to do is I'm going to split up our numerator. And so I'm going to actually split this into two separate limits. We're going to have the limit as f of x plus h times g of x plus h minus f of x plus h times g of x, and then this is all over h. Plus the limit as h goes to 0 of f of x plus h times g of x minus f of x times g of x, and then all over h. All right, and again, all we actually did is we just split this up into two separate fractions, and we're going to take the limit of them both separately. Okay. And next, I'm actually going to break this limit into two different limits. But actually before that, maybe we'll do one more step. Maybe one more. Okay. Let's factor in f of x plus h out of the numerator here. And so that gives us f of x plus h times g of x plus h minus g of x. And then this is all over h. And then we have plus the limit as h goes to 0. And up here, I'm going to factor out actually a g of x. And in parentheses here, we're going to have f of x plus h minus f of x. And then this is all over h. All right, just a couple more steps here. And actually, yeah, maybe we can get it done in 2 more. Let's pull this f of x plus h out front. All right, so we have a product here. So the limit as h goes to 0 of f of x plus h times the limit as h goes to 0 of g of x plus h minus g of x all over h, and then plus the limit as h goes to 0. And actually, let's pull something out of this one too. Let's pull out this g of x. And is what we're left with over here is f of x plus h minus f of x all over h. Okay. And you might be wondering, why didn't I write the limit sign in front of g of x here? Well, it doesn't have any h's in it, so it's not really affected by the limit. While this f of x plus h does have an h in it, so it will be affected by this limit as h goes to 0. Okay. So this limit as h goes to 0 of f of x plus h should just be f of x. The second piece here, this looks identical to the definition of the derivative of g. So this is times g prime of x. And then we have plus g of x times what looks like the derivative of f. And it is. So times f prime of x. Okay. And now this is the same formula we have up above. The terms are just in slightly different orders, right? For one, if I wanted to, you can switch the order of addition, right, with real numbers. So f of x times g prime of x here. And you can also change the order of multiplication with real numbers. So this I could rewrite as f prime of x times g of x plus f of x times g prime of x. We have our first example here that will require the product rule. And I shouldn't say it'll require it because we do have a way around it here. But we're going to use the product rule on it. And if we're going to do that, maybe for this first one, it might be helpful to think about which function is f and which is g. And actually, I could have swapped the order here. It doesn't matter actually which one's f and g. I'm just putting this here so that we can see how this fits our formula. If you were to take the derivative of x, right, was just 1. So you have 1 times 3. And the derivative of negative 2, well, that's 0. So I just get f prime of x is equal to 3. And g prime of x is actually just equal to 1, right? The derivative with respect to x of x is 1. Now, the product rule, it should look like the derivative of the first function, so f prime here, times the second function, which is g, so that's x minus 1. Then we have plus the derivative of the second function, which is just 1, times the first function, which was 3x minus 2. And you could simplify this. This is 3x minus 3 plus 3x minus 2, which is 6x minus 5. Okay. Well, let's say we didn't know the power rule yet, and we still wanted to do this problem. Okay. So if we were to take y here and distribute, we'd get 3x squared. We'd get minus 3x minus 2x, which is minus 5x, and then plus 2. And then if you were to take the derivative of that, right, the derivative of x squared is just 2x, so I have 3 times 2x. And then the derivative of x is just 1, so I have minus 5 times 1. And then plus the derivative of 2, which is 0. And so this just becomes 6x minus 5. Okay. So we could have done this by, again, foiling and then taking the derivative. Okay. But notice they're both the same. Okay. All right, let's try another one. And this one would be a good one for you to pause the video and try. All right, so if you've already tried this, let's see what we get. So if I were to take the derivative of the first function, which I'm going to call 4x squared here, you normally don't need to do this side work over here, but if you were to take the derivative of x squared, you'd get 2x, and then we have to multiply by 4. So we have 4 times the derivative of x squared, which is 2x, using our power rule. All right, and I'm going to give myself actually just a smidge more room this way, so h prime of x. So the first thing I should have is my derivative of f, which looks like is 8x. Okay. Then times the second function, which is sine of x, plus the first function, which was 4x squared. And again, I said that our second function, which we'll call g, is sine of x. And now we're going to need its derivative. Well, the derivative of sine of x is cosine of x. So this 4x squared here is going to wind up being multiplied by cosine of x. And there is our derivative. All right, and we have one more here. And the whole point in this example is to emphasize the fact that you don't always have to use the product rule if there's a product. And yeah, sure, there are plenty of times where we have to use it, but in part C here, this is not one of them. And here's why. I can take this and rewrite it a little bit, so I can have 5 times x to the 1/3. I could add the exponents on the x's, so it gives me 5x to the 4/3. Now I have something that I can just use the product rule on, or not the product rule, I can use the power rule on. Okay. So remember, if I want to take this derivative, this 5 is just going to hang out here, and I'm just going to take the derivative of this using our power rule. So we'll get 4/3 times x. And if you take away 1 from 4/3, it's going to leave you with a 1/3. And we could actually simplify this a little bit. This is going to give us 20 over 3. And then this is all times the cube root of x. And just as a note here, let's actually put this right here.